Both are held in a carriage. These parts are shown here in schematic form to demonstrate operating principles. There are two inputs. One input is time. It is represented by the disk which is motor-driven at constant speed. The other input is range rate. Range rate, coming from component solvers, moves or positions the balls like this. Range change is the roller's position measured in revolutions from its starting position and transmitted through an output shaft. The rotating disc, through friction, turns the balls and the roller. When the balls are near the edge of the disc, the roller turns at maximum speed. Roller speed decreases as the balls approach the disc center. And, at center, roller speed is 0. In principle, the roller and disc are comparable to a variable gear ratio, where the circumference of the roller and the track on the disc act as two gears. The balls act as idler gears. The circumference of the roller and of the balls, of course, is constant, but the track on the disc is variable. This is the equivalent of an infinite number of gear ratios. To make the mathematics easy to follow, suppose the disc turns 1 revolution per second, which we will show on this time counter. And at the output, suppose that 1 revolution of the roller represents 1 yard of range change. Range change will be shown by this counter. Then, with a range rate of 3 yards per second, this input places the balls in position for a disc-to-roller ratio of 3:1. The roller now turns 3 times for each revolution of the disc, and range change accumulates at the rate of 3 yards a second. A constant range rate is unusual. In most situations, range rate is always changing. This may be regarded as a progression of range rates, infinite in number, and with the integrator continuously computing each instantaneous change and adding it to the total output. There's one more point. The roller turns in one direction when the balls are this side of disc center, and in the opposite direction when they are on this side. One side is designated for plus range rates, with the output adding range change to initial range. The other side then is used for minus range rates, with the output subtracting range change from initial range. Thus, with any range rate, high or low, plus or minus, the integrator continuously multiplies range rate by time and delivers range change, which is the effective sum of all changes. Multipliers are mechanisms which can multiply 2 continuously changing values. We shall use this rack-type multiplier for purposes of illustration. Other types work on the same principle. The rack multiplier has 2 input racks A and B at right angles to each other, and an output rack. One input rack has a slotted pivot arm, which swings around a stationary pin. The other input rack has a slot which is engaged to the pivot arm by a sliding pin, called the multiplier pin. When either input rack moves, it changes the position of the multiplier pin. This pin also engages the slot of the output rack. So movement of the input racks positions the output rack. When the multiplier pin is lined up with the stationary pin, both input racks and the output rack are in zero position.